All right, so let's talk about number 7576 from 2.4. So 75 is asking about the idea of if you have an even function plus an even function, is the resulting function going to be even itself? So let's look at that first part, and then we'll look at the odd pieces. So let's make sure that we understand what an even function is. So remember, an even function is going to be a function that has symmetry across the y-axis. Okay, so something like this, like a parabola. Okay, where we have symmetry across there. So that means that any point, say on this side over here, is going to have a reflected value over on the other side. Okay, so if we're talking about this point as being x comma f of x, okay, that means that over here on the other side we're going to have negative x comma f of x. They have the same y value, just the only thing that's different is the x coordinate being changed there, which means that for an even function, that means that we're going to have a situation where f of x, okay, is equal to f of negative x. Okay, and if you think about that too, like if I took the original function, say y equals x squared, which is essentially what that function is on the left there, and I'm reflected across the y-axis, it goes right on top of itself. So that means that it does fulfill the requirement of being an even function. Okay, so going back to the problems from the book, if we're taking a look at two functions where f and g are even functions, pardon my handwriting, the question is f plus g even? Okay, so if we take a look at the definition that we have up top there, we know that f of x is equal to f of negative x, and by extension we could say that, I'll go ahead and write that down here, we have f of x is equal to f of negative x, okay, and we know that g of x is also going to have that same symmetry, so g of negative x, because it's also even. That's the premise here. So the question is, if we do f plus g of x, okay, remember we can either write it like this, f plus g of x, okay, or we can go ahead and write this as f of x plus g of x, okay. But for this problem, we're taking a look at, is it going to be the same thing as, it's going to have the same kind of type of symmetry that we're seeing up top there. So for this thing, if we want to actually see if those things are going to add together to give us those values, maybe we could say that let's investigate, instead of doing f of g of x, let's do f of g of negative x. Okay, so in that case right there, what we're saying is, what if we made all of our x values negative in both functions? Okay, how would that change the graph? Well, we know that f of x on its own, if we reflect it across the y-axis, which is the same as negating your x values, it's going to be the same function. Okay, same deal with g of x, same equation, same graph. Okay, so in this case right here, we can say that this is equivalent to f of x plus g of x. Okay, so no real changes happening in there because we know that they're going to be symmetrical across the x-axis. So that means that f plus g of x is also even. Okay, so thinking about this in terms of graphs and reflection definitely helps in terms of getting a better understanding of it. Okay, let's take a look at the second part of that question, which is if f is odd, or f and g are odd functions. Okay. So remember, odd functions means that they have symmetry across the x-axis and y-axis combined. So the book gives this definition. They say that negative f of x is equal to f of negative x. Okay, and we could do the same thing for g. So negative g of x equals to g of negative x. Okay, so really what that's saying here, like for example, for f in this case over here, if I'm looking at something where I have a function, say something like this, that's going to end up being having symmetry across the about the origin, as this does. Remember, that's a combination of two things. So this first left-hand side of the equation over here, this is saying that we're going to reflect across the x-axis because we're negating our y value. So it would be reflected down here, okay? And then it's saying that f of negative x, that's reflecting across the y-axis, okay, right here, which means that this would reflect right into that spot. So what we're saying is that if this is reflected down here and this is reflected over on this side, they're going to end up being the same thing. Okay, so that's one way to think about it, and that's the book's definition for it. The way that I looked at it in class, or I wrote it up in class, was also this, where the original function is equal to negative f of negative x. Okay, and that really just takes a look at both of the transformations, so the reflections happening at once. Okay, so either way is perfectly correct to write it out. So going back to the idea that we're looking at here was that if we know that f and g are both odd functions as they are here, then we could think about this as being, let's say, because we're looking at the sum of them, so f plus g of negative x we'll look at. Okay, so in this case right here, we know that f plus g of negative x, that's the same thing. We can write this out as f of negative x plus g of negative x. Okay, since we know that that's symmetry about the y-axis, well, it's got to be equal to if we did symmetry about the x-axis also. So I could, essentially I'm substituting in here negative f of x. Okay, maybe I'll put parentheses so we know we substituted right there, plus negative g of x. Okay, and since they both have a negative there, I could just go ahead and pull a negative out and rewrite this as f of x plus g of x. Okay, and really what we're showing there is that since they both have symmetry across the x-axis and across the y-axis, that means that the sum of them will also. Okay, so in this case, we know that this is going to be true, which is, and we know that this piece inside here, f of x plus g of x, is odd. Okay, so it still has that same symmetry, and that's actually going back to the full definition that we're looking for at the top there. Okay, so hopefully this helps. We'll talk more about this in class, and let's see if we can kind of bring it back to some more specific examples and getting into things that don't necessarily fit this. The idea of even and odd degree versus even and odd symmetry. Okay, all right, thanks a lot.